Okay, I think, there we go. All right. So, we're talking today about Chapter 2, Section 5, the very last piece of that section, which is solving rational equations. Okay, we've graphed them. We've graphed rational polynomials already. We've graphed them. We've talked about how to find all the various aspects of them: horizontal asymptotes, vertical asymptotes, holes, oblique asymptotes, all that stuff. So now all we need to do is talk about how to solve equations that are rational equations. Now when we do this, what we do is we have been going through here and doing the entire graph. Now all we're really doing instead is just worrying about where does it cross the x-axis? What are the zeros? What are the roots? What are the solutions? Okay, so all we're doing is solving for x. That's a relatively simple thing for us to do. What we do is we are going to be factoring any denominators. We'll clear all of the fractions out of the equation by multiplying the entire thing, all the terms, by the GCF of the denominators. We'll simplify and solve the resulting equation. And there is one big piece here that is extra, and that is when we get done, we need to make sure that the answers that we get are actually answers and not excluded values from the original equation. So for instance, here on example 1, we have x plus 6 over x minus 8. So remember that if we have something that's not a fraction in that equation, we can always put that item over 1 to turn it into a fraction. So when we consider our GCF, we consider every single term. Now, if we look at this, we should tell ourselves immediately, based on this piece of the denominator, x minus 8, that means that 8 is not in the domain because it is an undefined value for this equation. It would cause division by 0, so it is not included in the domain. Okay, and that's the first thing you should do, is think to yourself, what values is it not going to be allowed to use? Which values am I not going to be able to have as answers? And those would be any value that causes division by 0. So then we ask ourselves, okay, if I look at those three fractions, x over 1, 6 over x minus 8, and 0 over 1, what would my common denominator be for those three fractions? And it should be that binomial x minus 8 is the GCF. Okay, our GCF in this problem, our GCD really, greatest common denominator, would be that binomial factor x minus 8. So what we have to do to solve this problem is we have to take each factor and multiply each factor's numerator by x minus 8. Okay, now when we do that, what happens is our denominators will cancel because we're multiplying by the GCF. And in this case, in that middle term, the x minus 8 cancels with the x minus 8 and it goes away. So this turns into x times x minus 8 plus 6 equals 0, because 0 times x minus 8 is still 0. So then what we do is we solve that equation. So that's as simple as, well, we distribute, which would give us x squared minus 8x plus 6 equals 0. And then we ask ourselves, does that factor? Well, there are no factors of 6 that add to negative 8. So unfortunately, that means we have to use the quadratic formula. So we have to say, okay, A is 1, B is negative 8, C is 6, and we have to solve this equation. So quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, which would be 8 plus or minus the square root of negative 8 squared minus 4 times 1 times 6 over 2 times 1. That would be 8 plus or minus the square root of 64 minus 24, which would be 40 over 2. So x would be 8 plus or minus 2 root 10 over 2, or 4 plus or minus the square root of 10. Now, that is step 3. We've simplified and solved the equation, and that is not always going to require quadratic formula. In this case, the numbers just weren't very nice. Okay, we just have to use whatever skills we already have in place that we need to use to solve that resulting equation. Many times it will factor, but in this case, it just didn't factor. We got unlucky. So our answers are x equals 4 root 10 and x equals 4 minus root 10. And when we talk about step 4, where we check for extraneous solutions, all we really have to do is compare that list to the list of values that it's not allowed to equal. So we look over there and we say, okay, it's not allowed to be 8. Well, neither one of those answers are 8, so they're both going to work, and we're done with that problem. Okay, the extraneous step is literally just going back to the very beginning and saying, are any of the answers I just found in that list of excluded values? No? Cool, those are the answers. Moving on. Okay, so those would be our solutions for that first example. Would be 4 plus root 10 and 4 minus root 10. All right, moving on to the next example, unless I screwed something up. Anybody see anything I screwed up there? And again, that's an example of a quadratic that did not behave nicely. Usually those will factor. In fact, on the homework tonight, I don't think you end up having to use the quadratic formula at all. But it's always there if we need it. All right, let's go on to the next example. I'm going to scroll down here. Okay. So this one is a little bit more challenging looking. It's actually probably going to work out nicer and be less of a problem than that last one. Essentially what we do is we ask ourselves, what does this factor into? So we say, what are the factors of 8 that add to negative 6? Well, it's x minus 2 and x minus 4, which means that our GCF is going to be x minus 2 times x minus 4. And our excluded values are going to be 2 and 4, because those values are going to cause division by 0 in the original equation, which is a problem. So those two values, 2 and 4, cannot be solutions. If we get to the end and we get x equals 2 or x equals 4 as an answer, then we would throw that answer out. So we are going to be multiplying those three fractions by x minus 2 and x minus 4. So we multiply the top of each fraction by the GCF. When we do that, the denominators of each fraction will cancel, with those blue factors. So the x minus 2's will cancel and the x minus 4's will cancel in that first fraction. In the second fraction, the x minus 2's will cancel. In the third fraction, the x minus 4's will cancel, which leaves us with 4 equals 3x times x minus 4 plus 2 times x minus 2. The fractions are gone. We've cleared them. So now we just have to solve what is left. So in both cases, to get rid of the parentheses, we distribute. That gives us 4 equals 3x squared minus 12x plus 2x minus 4. We need to combine like terms, and we need it to equal 0 so that we can solve. So we're going to subtract 4 from each side at the same time. That will give us 3x squared minus 10x minus 8 is equal to 0. Now, this does factor. It's not the nice factoring because a is not equal to 1, but it does factor. There are factors of 3 times negative 8 or negative 24 that add to negative 10, which means, again, this is that advanced factoring. We do a times c is negative 24. We need a pair of numbers that adds to negative 10. That is negative 12 and positive 2. So we are going to break that middle term up, which would give us 3x squared minus 12x plus 2x minus 8. And then we're going to group to factor. So here I can take out a 3x, which leaves x minus 4. Here I can take out a 2, which leaves x minus 4. So my two factors are x minus 4, which is what's inside the parentheses, and 3x plus 2. Remember that to find the zeros, I'm going to take each of those factors and set them equal to 0. So here, this would imply that we have a 0 at x equals 4. And this one, well, if we set 3x plus 2 equal to 0, subtract 2, and divide by 3, we get an answer of negative 2/3. So in theory, this rational equation has two answers, x equals 4 and x equals negative 2/3. However, we then need to remember to check for excluded values. X equals 4 was an excluded value, which means that we are not going to be keeping x equals 4. That answer is going to get thrown out because it is not in the domain. So this equation ends up having only one solution, that being x equals negative 2/3. Okay, only one example to go. And more of the same. I think 3 examples is more than enough to get the idea here.
Mr. Wills.
Yes.
So when you subtract that 4 over, wait, why would you subtract it? Why wouldn't you add it?
Because I'm moving this 4, which is positive, not this 4. I know it's kind of confusing because they're both 4s. I need it to equal 0, so I'm subtracting this 4 to get it to equal 0.
All right.
Because to solve any quadratic, we need it equal to 0. Okay, now I am going to clear that off and scroll down as far as it will let me for example 3, because as you can see, these do kind of take some space to work through in an orderly fashion. Okay, so if you need me to put that back up afterwards, if you don't have it yet, that's fine. I can put it back up after we finish up the recording. So we're going to move on to example 3. So on example 3, same sort of idea. We need to factor each denominator, which on the first denominator we can take an x out. We can't factor either one of the other ones, but we are going to put parentheses around x plus 6. So our GCF for this problem is going to be x times x plus 6. Again, it's sort of a combination of all of the factors of the denominators is what our GCF ends up being. And our excluded values would be when those equal 0. So that would be x equals 0 and x equals -6 are going to be excluded from the domain of this problem. So we're going to take that problem, -12 over x times x plus 6 equals 2 over x plus 6 plus x minus 2 over x, and we're going to multiply each term by x times x plus 6. Again, the reason that we're doing that is to clear the fractions, to get rid of the denominators. So when we multiply by that GCF, that will cancel any common terms top to bottom. So in the first fraction, both x and x plus 6 cancel. In the second fraction, only x plus 6 cancels. And in the last fraction, the x's cancel. So we're left with -12 equals 2x plus x minus 2 times x plus 6. Which is the same equation, just with the fractions cleared. So we need to FOIL this. That needs to be our first step, is to FOIL that out. So that would be x squared plus 6x minus 2x minus 12. So that would give us x squared plus 4x minus 12. Then we need to get everything on one side and combine like terms. So we're going to add this 2x and this 4x together. And we are going to add 12 to each side. Now we get a little interesting thing happens that is not going to happen every time, and that is the 12 cancels out on both sides. We're left with x squared plus 6x equals 0. So we're going to solve that by factoring. We are going to factor out an x, which gives us x times x plus 6. And then we split it up and solve each factor individually, giving us potential answers of 0 and -6. But when we go back and compare those to our excluded values, both of those values were excluded, which means neither answer can be kept. They both have to be thrown away because they are not in the domain of this problem, which means our answer is no solution. Yep.
How'd you get your excluded values again?
Okay, back to the very beginning of the problem when I factor the denominators. I'm looking to see what values will cause the denominator to equal 0. So if x equals 0, that's a problem. And if x equals -6, that's a problem. So any number that would cause the original problem to have division by 0 has to be excluded from the domain.
All right.
Okay. Any other questions on this stuff?